Hello everyone, I'm Amir Hossein. This is another video for making cross-section plots for 3 overlaid variables. In the post-WRF directory, open namelist. In the cross-section plot, and for the first variable, let me change the variable name to something else. Currently it is dew point temperature. Let me change it to wind speed. But for wind speed, before changing it to wind speed, open a new tab and run postwrf-d. This command prints a list of variables, a list of diagnostic variables that you can choose for your WRF model output. In this list, at the end of this list, you can see 2 variables called wind_s and wind_d. These 2 variables stand for wind speed and wind direction, but just for the surface. But for a cross-section plot, you need variables with bottom-top dimension, not surface variables. So for wind speed that has a bottom-top dimension, you are supposed to calculate it. So calculating wind speed can be done by wind components, meridional and zonal wind components that you can see here, UA and VA. So UA stands for U component, or a west-east component of wind speed, and VA stands for south-north component of wind speed. So go back to the name list. Here I put opening parentheses UA to the power of 2 plus UA to the power of plus VA to the power of 2, closing parentheses, to the power of 0.5. This is the simple equation for calculating wind speed. And let me change the interval to 20 meter per second and the color to blue. For the second variable, this is virtual temperature, TV. If I go back to the list, you can see that TV stands for virtual temperature. But 20 degrees is okay for the interval. Let me change the color to red. And for the third variable, which will be a shaded contour, let me change it to a variable called cape. If you go back to the list, we have a variable for cape, but you should pay attention that you select the 3D cape. The 3D cape means that the cape that has bottom-top dimension. So I copy it and paste it here instead of RH for relative humidity. Cape 3D. Okay, I save it and I run post-WRF. I choose third one, and the first method, 1 point and angle. The pivot point, longitude of the pivot point, I will choose, let's say, 50 degrees. 50 is between 40 and 69. And for the latitude of the pivot point, I put here 33 degrees, something that is between this range. And the angle, let's say 70 or 50 degrees. Manual for the method of drawing contours. Minimum value for shaded contour, I put here, I push enter, so it will automatically calculate it. For the maximum, enter, so it will calculate, also calculate maximum value. And for the color of your shaded contour, let me choose number 7 as green color, and I will pick all time slots in the WRF file, and X11 as the format of the image. I'm not going to save it. And after a while, because the variable I put for the third variable I put for the shaded contour, it's a polynomial. It asks you the name and unit of this variable. The name of this variable is wind speed, and the unit of this variable of this of this polynomial is meter per second. And here you can see that we have three variables: cape, virtual temperature in red, and wind speed in blue. Through this path, you can see that we have a path here. If you follow this path, you can see that this path is going through Zagros Mountains. This area is actually Zagros Mountains, and you can see the heights of Zagros Mountains here in the plot.